All right. I'll do a quick introduction on Brad. So Brad Pinno is an assistant professor of silviculture at the University of Alberta. His current research focuses on intensive tree, stand, and forest level productivity. In addition to research, he teaches silviculture, forest operations, and introductory forest field school, and is one of the academic co-leads to the forestry industry lecture series. With that, you can take it over, Brad.
Excellent. Thanks very much, Andy. Okay, so I'm going to be talking about intensive silviculture and its effect on tree, stand, and landscape scale productivity. Okay, so this, I'm going to be presenting a bit of a case study here. It's mostly some modeling work, and really what we wanted to do with it is show the potential for it. That was really the goal of this project. So this was a collaboration between folks at the University of Alberta, which is me, Kazi Hossein, and Vic Liefers, folks at 4Corp, in particular Ted Gooding and Andrew Johnson. And the funding for this project was provided by Weyerhaeuser, and big thanks to Bob Winship, Dave Swindlehurst, and Kerry Mackay, who are a great help with this project as well. We've had a lot of great discussions about this project, actually, which has been really nice. Okay, so why are we talking about intensive silviculture in Alberta? And I like showing this slide, but the reason is we have very productive forests in Alberta. Alberta has the best soils in the Canadian boreal forest. This map on the top, I like to show it as much as I possibly can. It's an old map from NRCan on timber productivity across Canada. The darker the color, the more productive the forests are. The most productive forest coast in the coastal BC, but across the boreal, it's Alberta. The big green spot in northern Alberta, that's our boreal forest, and that's the most productive forest, boreal forest in Canada. So if we're going to be looking at intensive silviculture, this is a great place to do it. Other places have shown about a 3 to 4 times yield increase with intensive silviculture, whether it's New Brunswick or Scandinavia or Pacific Northwest or Southeast United States. There's no reason we couldn't expect that here as well. So natural stands we might be dealing in the range of 2 to 4 cubic meters per hectare per year MAI, 70 to 100 year rotations. With intensive silviculture, I think the potential is 6 to 8 cubic meters per hectare per year MAI and 50 to 60 year rotations. And in reality, I think that's where we're at right now. So maybe that's the minimum potential. Maybe the potential is actually even higher than that. We'll see as this progresses. Okay, so what do I mean by intensive silviculture? We've heard a lot of these terms and already today, but really we're talking about plantation management, where combinations of site preparation, planting good quality stock, planting the right genetics, and then also controlling competition. Okay, the next part of this is really the density management and site selection, and that's really what I'm going to be talking more about today. Are these last two: density control and site selection a little bit. At the landscape scale, we're talking about timber supply analysis. What's the effect of intensive silviculture, not just on an individual stand, but across the whole landscape. And this involves some sort of zoning, whether that's lines on maps of different intensity zones, or whether it's just understanding what the distribution of different site qualities is across your landscape. But it's some sort of understanding that, and I like that term that Tyler used earlier, this idea of more precision silviculture. That's kind of where we're getting with this idea of knowing more about the individual sites that we were implementing this. Okay, so this is a case study from the Pembina FMA. So this goes from Edson to Drayton down to Rocky Mountain House. And so Weyerhaeuser established a network of about 100 regenerating stand PSPs, and that's where we got our data from this. We went and validated some of the height measurements for our site index measurements. And then we were able to model different yield curves for different treatments from these regenerating stands. So we used MGM to model these different scenarios, and then we used patchwork to model the impact across the entire FMA area. So let's talk a little bit about this landscape. This is a fairly common landscape distribution in Alberta, but it's an old forest. You can see that top figure there, that's an age class distribution graph. Most of the forest is over 100 years old, so those old forests are declining. They might not be putting on much volume, or they might even be declining in volume. They're also at risk of fire, insect and disease, that sort of thing. But that's essentially what we're harvesting right now. So the challenge with this is that we don't have much young forest, and this results in this midterm timber supply gap. So one of the questions is, can we use intensive silviculture and thinning to maybe bridge that timber supply gap, as well as can we do it, is there something we can do to allow us to access more of the existing mature timber on the landscape? So the other thing to think about is the species composition of the forest, and this forest is about half productive forest, so the active land base is about half of the total area. The other half is in different deletions. And of the active land base, about half of it is conifer. And that's really going to be the focus of what I'm going to be talking about here today, is really the conifer portion of the landscape. Okay, so different silviculture scenarios. We had all these PSP data, and then we were able to model different scenarios. So we focused really on the different thinning treatments. So another part of this project was a variety of different treatments, pre-commercial thinning or PCT treatments in combination, different timings, different intensities, combined with different commercial thinning treatments or CT treatments. So what I'm going to be presenting here as our thinning treatment was a combination of pre-commercial thinning and weeding at age 14, plus a commercial thinning at age 35 or 40, depending on site quality. And so what we did is we divided up our PSPs based on site index, okay? And then we developed yield curves for each of these different site index groupings. So 23 plus is our good site index or site qualities, 19 to 22 or 23. We used 23 with pine and 22 with spruce as our good sites. That's the only difference there. And less than 19 was our fair site. And we developed thinning yield curves for the good and the medium quality pine and spruce sites, just the pure conifer stands, okay? So I mentioned site index, and this is one thing that I want to mention, because this is one of the most interesting things we found right off the bat with this study, is that it looks like site index is increasing over time. So these PSPs are range in age from 40 up to down to the newest ones are being established now. But what we see is that site index is increasing over time. And why is this? I think the biggest reason is better silviculture. We're planting better stock, we're planting better genetics, we're doing a lot better competition control and site prep. Is there a climate factor? Potentially, but I think most of it is due to better silviculture. But in the older stands, the average site index was around 18. Now, in the last 20 years, the average site index was more like around 23 from these regenerating stands, okay? That's not the same as site index in the natural forest or in naturally regenerated forest, but in our post-harvest forest, the site index is clearly increasing, okay? And about half of our sites are on this, what we're considering a good quality site, so site index greater than 23 in the pine or greater than 22 in our spruce sites. So that's probably a lot higher than most people would think, but that's the reality of what we're seeing here is site index is quite high in many of our regenerating forests, and maybe that shouldn't be surprising given that first slide with what we know about the productivity of Alberta's forests. Okay, so let's get right into some of these yield curves that we developed. So for each of these groups, so we have pine on good sites, we have pine on medium sites, and we have pine on fair sites. We had 3 to 5 PSPs from each of those categories, and then we modeled different scenarios, and then we averaged them to develop these yield curves here. Okay, so that's the process we went to get at this. And the thinning here again is a combination of pre-commercial thinning and cleaning at age 14, plus a commercial thinning. That's the scenario that we use for our thinning treatment in this example here. So the first thing with these yield curves is that site productivity is the main driver. Okay, so as we move, that's those curves on the top right there. The bottom one is the fair sites. And as you move from fair to good sites, the productivity about doubles as you go in terms of pine volume, okay, with a medium site somewhere in the middle, okay? So clearly, site productivity is the major driver of our yield curves here, far more so than our treatments. And actually, in reality, with our these are merchantable volume curves, the thinning treatment had very little effect on the total merchantable volume. You can see it with the pre-commercial thinning actually was a little bit higher than the control ones with no thinnings, and then it drops down after the commercial thinning. And it stays a little bit below that line after the fact, but in reality, there's not a whole bunch of difference in merchantable volume at the stand level with thinning, without thinning. Where the difference is at the individual tree size. And that's that bottom figure, okay? And thinning increases individual tree size. We know when we thin, we're directing all of the resource from those sites to the fewer remaining trees. The trees are going to grow better. They're going to grow bigger, and that's what we see. So on that bottom is we have individual tree size, and you can see after the thinning is where we get those. It really takes off the individual tree size, and by thinning, we almost get a doubling of the individual tree size on average between the thinned and unthinned stands. So thinning increases individual tree growth and the merchantability at the individual tree. We also want to look at the stand level though. So one of the things we did is the total volume isn't all that different with thinning, without thinning, but there's big differences in the distribution of the tree sizes on those sites. So we weren't exactly sure what the metric should be here. We ended up coming up with this metric of trees greater than 20 centimeters DBH. Those are what we're considering good saw log trees. Is that the right metric? Maybe, maybe not, but at least it's the starting place for our discussion here. Maybe it's 18, maybe it's 24, I don't know. But so we'll go with 20 for right now. And what we were able to do is we compared stands with thinning at age 50 versus the same stands without thinning at age 80. Okay, and let's walk through this figure here. Okay, so that's just the diameter distribution, the number of stems in the different diameter categories. So with thinning on our good pine sites at age 50, we had 548 trees greater than 20 centimeters diameter. Okay, so that's pretty good. Without thinning at age 80, we only had 520 trees greater than 20 centimeters DBH, and we had a huge number of smaller trees or pulp logs, as well as unmerchantable trees below the merchantability criteria altogether. So completely different stand structures. And in reality, what this is telling me is that by thinning, we sped up merchantability of the stand by about 30 years. So that's huge. Instead of the stand being ready for harvest at age 80, we're down to about 50 with thinning. So that's huge. So thinning reduces or increases merchantability and reduces age to harvest by around 30 years, it looks like. I'll mention briefly about the spruce. We did have our spruce PSPs as well. In general, it was the same sort of thing as site quality is by far the major driver. One of the challenges we had with the spruce curves, though, is that many of the spruce stands were understocked, and many of them under 1,000 stems per hectare, or sometimes even less. The trees that were there were growing very well, but they weren't fully stocked stands necessarily. So this was a challenge. So what we actually did is we're calling these potential yield curves. And what we did is we added average spruce tree size into some of these plots in order to create these yield curves. And so going forward, we could create these stands, we could grow these stands, but they don't exist on the landscape today. So that kind of comes to our question of what can we do on our landscape today to affect the overall AAC across the landscape. And in reality, there wasn't a lot that could be done with the spruce stands right now because many of them were under stock. The pine stands were a different story, but the spruce stands were not. So that's going to have an impact on what we could potentially be doing with the timber supply modeling, or what we could be doing now across the landscape. Okay, so let's get into some of the patchwork. So this is the landscape scale analysis. So we use patchwork for our timber supply analysis, and the yield curves fed into patchworks for conifer are from the yield curves we developed here. For the mixed woods and deciduous stands, we use their existing yield curves from the forest management plan. The basic assumptions we kept the same, at least to start with, things like minimum harvest age, 71 for deciduous, 81 for mixed wood and conifers, even flow, only 5% variability over time, 1511 utilization was the standard. We also kept the landscape constraints related to watersheds and wildlife habitats. So we tried to be similar to their existing forest management plan as we could. So let's talk about the thinning here quickly. So the thinning is where we could make a lot of decisions here. And we had thinned and unthinned yield curves for both the good and medium quality pine and spruce sites. And we said that up to half of that area could potentially be thinned. That's in the modeling environment, it was allowed to select up to half of that area to be thinned. So the rationale behind that is some areas will be inaccessible, some will be used to meet other landscape objectives, wildlife, things like that, or won't have the stocking to do it. That sort of thing. Maybe that's not the right number, but it's a good place to start, I think. And again, so up to half of the conifer land base could be thinned. Okay, with the pine, we could thin those stands now if we wanted to. If we wanted to convert our existing pine stands and put half of them onto these enhanced yield curves, we could do that right now. But the spruce, it would only take effect on stands that were started as of today. So moving forward, we could start applying those spruce yield curves because they just didn't exist on the landscape yet. And for the modeling we did here, we have 4 different scenarios, so the baseline and 3 other scenarios. The baseline meaning no thinning treatments were applied at all. And I'll run through those quickly now. Okay, so the baseline scenario, and we're going to focus on the conifer AAC, annual allowable cut. But the baseline scenario with no thinning at all was 1.185 million cubic meters of conifer. Okay, so what if we applied our thinning regimes but didn't change the minimum harvest age? So if we didn't change the harvest age, it really had no effect on the annual allowable cut. So if we applied thinning but didn't change the minimum harvest ages, there's only a 0.4% increase in AAC. So essentially, you need to be able to utilize shorter rotation ages if you're going to have any benefit from thinning. Okay. Next one there. With reduced harvest age, but not starting in the future. So we're only going to apply it to stands moving forward. We're not going to do anything to any stand that's on the landscape right now. And by doing that, by applying these thinning prescriptions in the future, we actually saw about a 5% increase in AAC. And so what we did with this is we had a reduced minimum harvest age on stands that were thinned only, okay? So if they were thinned, they can have a minimum harvest age of 50. If they were unthinned, then the minimum harvest age was still 80. But even by doing that, we had a 5% increase in a 5.6% increase in conifer AAC. And the last one here, what if we started working on this now? So what if we started our thinning, we had the reduced minimum harvest ages for our thin stands, and we actually started thinning the pine now. And with that scenario, we got a 10.6% increase in annual allowable conifer harvest, up to 1.31 million meters cubed per year. So that's a significant amount, okay? So the point of this all is that at the landscape scale, thinning increases total merchantable conifer annual allowable cut. So we tried to look at this at different scales here. So I want to look at that last scenario a little bit more here for just a couple of seconds. So that's the 10% increase. So we had a 10% increase in even flow conifer AAC. And so the top figure there is just the area thinned each year. And it's actually the commercial thinning, but remember that's actually about the same as the pre-commercial thinning because it got applied to both of them. And on average, it was about 1,000 hectares of thinning per year, resulting in about a 10% increase in conifer AAC. And now we can start playing with some of those numbers. Okay, what if we thinned a little bit more? What if we thinned a little bit less? What impact is that going to have? And that's what we wanted to see with this project. So that was really interesting. And the other question, of course, that came up is, well, what if we would have started thinning our pine earlier? What if we could have accessed or started thinning some of the spruce stands now as well? What could that potential have been? So it's an interesting discussion to have. The bottom graph there is where is this wood coming from? The red is the existing natural stands. And what we see is for about the next 40 years, we're harvesting only natural forest. So even though we're putting a lot into the silviculture of these stands, we're still not harvesting them until we've finished harvesting all of the natural forest. Okay. The other thing to note here is that this silviculture, even though the real benefit of it was the silviculture was on regenerating stands, but the real benefit, I think, or one of the major benefits, was that ability to access that existing mature forest now and increase the access to it by about 10% immediately, starting today, potentially. So that was another interesting one. It's kind of like a pseudo allowable cut effect. Okay, so a couple other things here, future analyses. I tried to give you a bit of an overview of the project that we were doing here. There's lots of other questions that we've got and lots of other parts of it. But I just wanted to give you a bit of an example here. But what if we were able to apply the allowable cut effect in a better way with some sort of a surge cut right now, recognizing the future potential increased productivity of our forest? And that's the next step that we're working on here. What if we focused on just the bigger saw logs, referred to as prime saw logs, like that's kind of like that 20 centimeter, instead of using the 13.5 centimeter standard cutoff for a merchantable tree? What if we looked at, stabilizing the saw log production from our forest? And when you're doing that, then it puts even more emphasis on thinning the forest and producing larger trees. So again, it's not just total volume, but it's the quality of the volume that is being produced. And other things, what about other forest protection values, whether it's drought, fire, insect, and disease? Thinning has the potential to reduce the risk of all of these. So if we start valuing these other aspects of the forest, which we've heard a lot about today, then again, thinning becomes more valuable as well. And what about markets for small diameter wood? Right now, there's an overabundance of small diameter wood, which limits the amount that we might want to be commercially thinning. But what if that's not the case in the future? It really does change the decision-making process. And I only focused on the conifer yield curves here today. But what about intensive management of mixed woods and deciduous stands? There's lots of potential in those stands as well, often through density management. And I think that's another step. We can look at intensifying our management across the entire landscape, not just in the conifer land base. Okay, so take-home message. Intensive silviculture is possible in Alberta. We have very good quality growing sites. We have productive forests. And by managing them, we can make get the most of them. Thinning increases individual tree growth. Thinning increases stand level merchantability, and it increases landscape level AAC. So thinning, lots of benefits for it. In this case study, we tried to start showing that, getting that message out there a little bit. And finally, just incorporating other forest values will probably make intensive silviculture even more important. As our active land bases continually reduce due to land-based deletions, things like that, the value of our remaining timberlands are going to become even more important. And so managing them more intensively is likely what's going to happen. I think we have the potential to do it in a very good way here in Alberta. But with that, we'll leave it there.
Thanks, Brad. Thanks for that excellent presentation. We'll open it up to questions for you. There is a quick question. Was your thinning a thin from below so that you're taking the smaller diameter trees out of the average?
Yeah, so we did, they were simulated thinnings, of course, but we did it from below. In reality, that's probably not what would happen. Even with having trails through stands, you're going to be cutting out some of the bigger trees, and even just, that's probably not the reality of how it would actually happen. But that's how we started it. I think there is some, it's a worthwhile discussion as to what a more realistic scenario could have been for these stands, but you can be looking at the spatial patterns of these forests and which trees would we actually be removing. And by doing that, we'd probably even get a bigger growth increase, because if you think about it, by just removing the small trees, they're the ones that are going to die anyways, so they're not really having that much of a competitive effect on the bigger trees. So we're not really getting, if you're just worried about the dominance, you're not really getting much of a growth benefit by just taking out the intermediate and suppress. You really need to get into starting to thin out some of the larger trees to have much of a growth response. We saw a little bit. I think we could see even more if we moved into a different thinning regime. The trade-off there might be longer rotations depending on how much volume you take off, but perhaps you can, thinning from above or, across the spectrum, you might be able to access more volume at the commercial thinning time versus, at the final felling time. So there's lots of details to be worked out, and that wasn't, we started talking about some of those, but we really wanted to demonstrate the potential for thinning across the landscape, and now the next step is really working on refining those scenarios.
Perfect. I'm just having a quick look here at one of the last questions. This will be, if it's a question, then it'll be the last question. All right. We also be investigating allowable cut effect, or ACE, from including commercial thinning as a potential treatment in the forest model?
Yes. So this is the allowable cut effect is one that we have struggled with more than anything else. And I don't know how to apply it, and that's one of the challenges that we're having. So, you know, it's right now we're looking at applying it as a bit of a surge cut right now for, say, 10 or 20 years to access some of the existing timber before it declines too much. And what is a thinning regime? How much thinning do you need to mitigate that downfall after that surge cut potentially? These are kind of gaming scenarios to some degree. And I don't know if any of this is actually happening in Alberta at all or not right now. But I think these are the scenarios that we need to start playing with a little bit. One of the values of the intensive silviculture is not just in that individual stand when it reaches maturity, but across the landscape, being able to access more timber today. So we have to be including allowable cut effect in these analyses somehow or another. The real challenge for us right now is it's not clear how that is done, or how that should be done, maybe is a better way to put it. But I think it's important to include. And actually, I think we're meeting tomorrow to with some of the group members to talk about how we start implementing that exact thing.
Excellent. With that said, I'd like to thank you, Brad. That was an excellent presentation. What we're going to do now is we're going to take a break until 2:30, and then we'll reconvene at the table. So the second discussion seminar will happen from 2:30 to 3:15. So when you come back from your coffee refill or whatever break, you can visit the speakers at their respective tables. I do believe Tyler Niles was unavailable for this afternoon, so his table could probably be used as a general knowledge exchange table. So Brad, do you have anything else you want to add before we reconvene at 2:30?
No, that's it. So again, at 2:30, we'll just come right back into the tables. We won't have another plenary or anything like that. We'll come right back to the tables in 10 minutes. We went a little bit over there. Sorry about that, folks. We'll come right back at 2:30 and right to the tables for the discussion. And yeah, I look forward to another great round of discussions then. Thank you.